Hi guys, today's notes are on chapter 4.1 and this is our first section in chapter 4, which is polynomial functions. So we are just going to intro some vocabulary today. We're not going to do any calculations. We're not going to be really doing very much, but we're introducing some ideas that will help us in the future with other sections. So the first thing you need to know is what is a polynomial function. And a polynomial function is an algebraic expression that involves only the operations addition, so something like this, subtraction, such as like x squared minus x, and multiplication. Knowing that like x times x is multiplication of variables, right? So we're adding, subtracting, and multiplying variables. That means we can have any exponent that we want, right? Because x times x is x squared, which is how we simplify things. So things that are not polynomials, things like absolute value. Okay, so this is not a polynomial function. Variable exponents. So not like x cubed, but things like 3 to the x power. We haven't touched on those yet, but next semester we'll see that those are not polynomial functions. And square roots. Okay, that's not a polynomial function. We are going to be using division, but one thing you should know is that you cannot have a variable in the denominator. Okay, so division where x is in the denominator doesn't count either. So like if you had x plus 5 over x minus 2, this you can't just cross out the x's, so this is not a polynomial function. So quick vocab, standard form of a polynomial. We've done standard form of quadratics already, where it's x squared plus, ax squared plus bx plus c. And hopefully you remember that it goes from x squared, x's, and then no x's. Well, now that we can extend that to what a polynomial is, polynomials are, instead of quadratics, where it's just x squared as the biggest exponent, polynomial exponents can be any number. Okay. And how you write things in standard form is a term with the biggest exponent first, and then write terms in descending order or decreasing order. Of exponents. Write terms in decreasing order of exponents. So the biggest exponent first, and then it goes down. So if I had x to the 5th power, it'd be x to the 5th, x to the 4th, x to the 3rd, x squared. So let's take a look at what that looks like here. If I gave you an equation or a function that's all mixed up, what you need to do is sort of make sure that you take the sign with each one. Okay, so the first thing is to recognize how many terms there are here. There are 5 terms. Notice I'm circling the positive or negative in front of each one. And our job is to put it in order with the biggest one first. So that'll be this one, right? Because 3 is the biggest. It's this one. Okay, so I'll have negative 5x cubed. The next one here, 2 is the biggest next. Okay, so then plus 2x squared. Notice I'm not looking at the numbers in front, I'm looking at the exponents. Then this will be minus 1x, which is to the 1 power, and then plus 10. I always do a check. 1, 2, 3, 4 terms, 4 terms. So let's do standard form here. You can also circle as you go, right? So I know x to the 6th is the biggest exponent. There's no x to the 5th, so x to the 4th is next. And then x squared, negative x, and then negative 5. Okay, these two are for you to try now. So please try standard form and standard form. Okay. After we do all of this, I'll write in my answers so you can check them. But try it yourself first. So pause the video and then we'll go from there. Degree of a polynomial has a different definition. It's the maximum number of variables in any one term. Okay, so it's not like x 1, 2, 3, 4. Okay, that's not what a degree is. One term, which means like this one, right? This one has 6 x's. So for instance, if I had x cubed, then it would be x times x times x, right? And so that would be a maximum number of 3. Well, in this one, there are 6 total here, so the degree would be 6. So here's my degree of 6, right? Here, the most I have, there's 2 x's here, 1 here, there's 3 here. Okay, so how can I rewrite this so it's the easiest to know? Well, a degree is the largest exponent. Take a moment, fill in the degree. After you have standard form, the degree should be really easy to spot. Notice I didn't say the first exponent because it's not always the first exponent. It's the largest exponent. Okay. Lastly, leading coefficient. Coefficient is the number in front. So it's the number in front. Okay. But leading means the very, very first number. Okay, the number in front of the first term. But this has to be in standard form. Okay, so it's really important to put things into standard form. So I'm not going to look at this number in front. I'm going to look at the number in front here. And so that'll be -5. And the number in front here is 1. So I'll draw some arrows so you guys can take a look. This is my exponent, and -5 is my number in front. Exponent, number in front. Okay. Last 2 for you to try. Fill in the leading coefficients. Okay, I'm going to pause the video. I'll write in my answers, but hopefully you've been writing in your answers as well. I wrote in 1. I didn't write in the second because if you're doing this on your own, I don't want you just copying your videos. So please write that in. So moving forward, let's sketch some different functions. So far we know that linear functions are a straight line. Okay, they do go forever. This is x to the 1 power. Quadratic, that's x squared, right? And we know that quadratic functions look like this. Cubic functions we haven't talked about very much yet, but they look like this. Okay, not the parent function, sorry, it's just functions in general. Quartic, x to the 4th will look like this. The next one will be x to the 5th, x to the 6th, and it's going to go up, down, up, down, up. And then 6 will be down, up, down, up, down, up. Okay. Well, if you take a moment, please fill in x to the 7th and x to the 8th. Hopefully you see a pattern. You notice that all the odds are starting from the bottom and all the evens are starting from the top. And I don't know if you've noticed this, but if it's going up here, that matches. Sorry guys, I had a student pop in. Where was I? Oh, okay. So this one, like there's only one direction right now, so that correlates with that. If you take a look here, there's one downward slope, which is negative, and then one upward slope. So there's 1, 2 different slopes. So that correlates with that one. This one has 1, 2, 3. And this is not a coincidence, right? Like the number of positive, or slope changes, I should say, matches with what you see. I should talk about also sometimes cubic will look like this. And so this counts as 3 too, because you have one here, one that's flat, and then one up. So that degree is still 3. Sometimes the humps or like the ups and downs are not as obvious. Okay, so this one's down, up, 1, 2, 3, 4, 1, 2, 3, 4, 5, down, up, right? And there's 6 here. So now if I do this one, up, down, 3, 4, 5, 6, 7. And then this one, hopefully you can draw in as well. Okay, make sure you start in the right place and then go ups and downs until you get that right. So what do you notice about the number of turns? Well, let's not talk about number of turns. We should say number of slope changes. Right? So it's like positive, negative. The number of slope changes equals to the degree. Oh, with 2 E's. So how is this helpful? Well, let's take a look. Today we are going to talk about also end behavior. Before we move on to graphs, let's talk about end behavior. The end behavior of a graph is what happens to y or what happens to your graph. Okay, we usually use y or f of x for your graph when x approaches infinity. So we're going to talk about positive infinity and negative infinity. Now, first things first, before we talk about anything, we need to figure out how to draw infinity. Please don't do 2 circles. I want you guys to practice with me. What it is you're writing the letter X without lifting your pencil. So if you go X, X, okay, and I'll show you again. Ready? So here's our first part of the X. There's your X. Down, swoop up, come back, and then connect. Okay, so do it again. Down, come back, right? So it's just an X without lifting your pencil or pen. Now, if X is approaching positive infinity, that's this side on the right, right? All positive numbers are on the right side. And then negative infinity is on the left. This year, we are going to focus just on X approaching positive infinity, okay, in our class. In future classes, we'll have to describe both of them. For right now, we just want to talk about going to the right, which is like where will the graph end up, okay? So to determine to the end behaviors, you need to identify and use the leading coefficient and degree. Oops. And degree. So the leading coefficient helps you determine what the graph does as we move to the right. What f of x, or the graph, as x approaches positive infinity, which means we're going to the right. Okay, so like on the end, at the end of the graph, as we read from left to right. And so if you have a positive leading coefficient, which you find by looking at the number at the very beginning, right? This -5 tells me that my graph is going to end up going down. And if you have a positive, say 1 here, I know my graph is going to go up. Okay, I'm going to call this positive leading coefficient. And then negative goes down. Okay, so if you have a positive leading coefficient, we go up. If we have a negative, it goes down. This is how I, as a teacher, check really quickly if a student got something right or not. So how do you write it on a test, right? So mathematicians want to find symbols to shortcut, I guess, or to summarize sentences without having to write a paragraph. So let me describe this end behavior. As x approaches positive infinity, f of x, or the graph, approaches positive infinity. And all I'm saying here is As x approaches positive infinity and the graph ends at the right, what happens to the graph? It goes up. So let's write this one now. As we go down, so as x approaches positive infinity, be careful here because this is still right. Okay, we always end on the right. F of x, the graph, goes down, which is negative infinity. Just a reminder, the degree helps you determine how many positive or negative slopes there are. Okay. Now, you need to start going backwards. When you sketch a graph, we end up going up right now, right? So you, start up or down, depending on the leading coefficient. Start on the right, I should say. Okay, this is really important. Depending on the leading coefficient. So up is positive, down is negative. And then you're going to go backwards to sketch the correct number of slope changes. So what does this mean? For example, if I had negative 7x to the 7th power plus whatever random stuff there, and I wanted to sketch a graph, well, I know that negative means that it's going down here, right? And then I'm going to go 1, 2, 3, 4, 5, 6, 7. I have no idea where the turns are, what it crosses, the y-intercept or whatever, but I do know that it's going to go up and down 7 times. Okay? And I know that it's going negative because my negative 7 comes here. Oh, I shouldn't have used negative 7. Let's change that, sorry. That confuses things. Let's do negative 2. So the negative 2 for my leading coefficient is what changes it, not the 7 here. Okay, so now let's put this all together. Okay. On your homework, what you're going to be asked to do is looking at a graph, you're going to identify some information and then match using this equation, using this graph and this information, you're going to figure out which equation that you're given matches with that graph. So you guys see how this goes? 1 slope, that means the degree is 1. 2 slopes, degree is 2, right? The y-intercept on the graph is always on the y-axis. So this one's 0, this one is 2. Leading coefficient. Now, I don't know if the leading coefficient is a number yet. Okay, there's no easy way to find this. But what you do know is that this is a positive leading coefficient because it's going up. This one is also positive leading coefficient, right? And I think now I could also write the end behavior. As x approaches positive infinity, f of x approaches. So as I'm going to the right, let me write that in, because that'll help you. We always read towards the right. The graph goes up. So let's think about this one now. As I read from left to right, positive infinity, the graph goes positive, which is up. Let's do this one now. This one, see if you can figure it out yourself. What's the degree? Hopefully you got 3. Where's the y-intercept? Right here. Leading coefficient I know is negative. Okay, and so far notice I don't have a number yet. We do need to fill that in, but we can't do it yet. But we can write the end behavior now. As x approaches positive infinity. Okay, I know it's going down, but it doesn't change anything. I'm still reading from left to right, positive. F of x approaches, and it's not going up anymore, so it's not positive. This is the only thing that could change in your statement. Approaches negative infinity this time because it's going down. So let's now figure out how this connects to our equations. There's no way to know where I got these numbers from. Okay, I have to give these to you. I will say though that the y-intercept in a graph is pretty clear. Right, so these numbers right here are the y-intercepts. So that also helps us get started. This one, the y-intercept is 0. And when we know that the degree is 1, that means I have x to the 1 power. And so we will go and scan our equations. This is squared, cubed, so x to the 1 power is either a or b. And how do we decide what it is? The y-intercepts both match 0. Okay, so that's not helpful. But one of them has a positive slope and one of them has a negative slope. And so we know that since we're going up, then this must be a positive slope. Okay. This one is a degree of 2. That means it either has to be c or d, because degree of 2 means it's x squared. Well, one of them's positive, one of them is negative. If our leading coefficient is positive, then it has to be this one, which means my leading coefficient is 0.5, and sorry, this one I forgot to fill in, is 1. So you have to look at the equation. Okay. This one is cubic, which is E or F. It's going down, so it's negative. So that's F. And then the leading coefficient is -1. Okay, that concludes our lesson. Sorry that was a little longer, but hopefully that was completely, I just wanted to make sure I explained everything.